Hello, I'm Joe Azuzu. Who's Joe Azuzu, and why is he in my video? All I could say about that is Farfanugan. For those that have been waiting for this item, today is your lucky day. Today we're going to look at and work on and kickstart this HP 3580 Alpha audio spectrum analyzer. They produced these from about 1972 through, I believe, about 1980, give or take. I do expect you to fact check me and ensure that I'm, staying on topic here. My version right here, I believe, is a 1974 model. The frequency range that this thing covers is 5 hertz all the way through 50,000 hertz. And this also has a tracking oscillator, which is would be fantastic for those that are designing, I want to say cavities, but filters, stuff like that. It has a dynamic range, display range, 10 dB in the log mode, which is greater than 80 dB. I know this makes me sound very intelligent, like I have an idea of what I'm talking about, but in all actuality, all I'm doing is reading out of the book. This is most definitely something that you could do as well. Read the PDF. And in fact, I think I'm going to shut up and let you do that. I do want to say one thing, that you are able to shove, I believe, 100 volts AC and 50 volts DC into this thing. And I do believe that's peak to peak. Again, fact check me and read the PDF yourself. It might be a really fat, thick PDF. Well, I know it is. It's 240 some odd pages the PDF is. The book that I have is actually from 1975, I believe. And it does cover my model, not a problem. One nice thing about the PDF, and then we'll get into this, is the PDF, not only does it cover the newer model, but it also covers the older model. It actually has a section in the background, just like, or in the back of the book, just like this does, that talks about backdating. So even though the digital PDF would have been just fine, the thing I found wrong with it was thumbing through, looking at these schematics. And trying to fold them out. We just go on and on. So I thought the book would definitely be the better option. All right, let's move on, shall we? Here on the front panel, it's pretty much self-explanatory, a lot of it. I went through and I dorked with it. For the most part, figured it out before I downloaded documentation. We have control here, intensity. I mean, a lot of it's self-explanatory. Intensity is for the scope. Adaptive sweep, you leave it in the auto position, or off position rather, and that'll leave the floor for the scope, depending on your setting, at the bottom. But if you need to, you can adjust that floor level wherever you would like it. Focus for the well, everybody knows what a focus is. We have, this has, it's digital, meaning it has memory, and I'll show you that a little bit. You can capture a waveform and play it back, and then compare it with another waveform. So if you're testing channel 1 and you want to compare it against channel 2, then you can just simply bring that up. Or you're testing frequencies or whatever. And then you can erase that. Not sure exactly what blank store is. I'd have to read the manual. Or as we'd like to say in the industry, RTFM. Power indicator light, the on-off switch. This does have means for a battery if you have that option installed. As far as I know, this does not have a battery installed. I have opened it, but I have not tore it completely apart, and we're probably going to do that to some degree. You have your options here of linear or log, and then we have our control here for our amplitude level. We have dB log in or balanced 600 ohm. We have our input sensitivity, so basically it's kind of like a mic gain or a gain to amplify your weak signals. We have our input, front panel input. This is our sweep time, so the faster you want the sample to happen or slow. I find that depending on what you're doing, there's really no one set number to leave it at. You will have to adjust that to some degree. And this here does mess with the floor. And then we have our bandwidth control. I find anywhere between 30 hertz and 300 hertz is just fine. And then we have another control right here. Not sure what that does. I mean, I see what it does visually. I don't know the name of it, but for the most part I leave it here in the left-hand position. I'm really not the one to be training or educating you. I'm really just glazing over this, and I have great expectations that if you're really interested in this, that you will read the manual. I am no voice of authority on this device. I'm no voice of authority on the topic. This is a recent acquisition for me, just like that word is, and the first time I've ever played with such an instrument. So by all means, research, read the manual. You'll probably understand more about the device than I do. As I stated in my Christmas Toys 2018 video, the bulk of this device will probably be lost on me. The few little things that I'm going to do with it, I'm hoping for repairing of audio equipment, even tuning up radios and whatnot, that this will come into play for that. Time will only tell how I use it, if I use it, and why I use it. Over here we have our frequency span per division, and can't remember exactly what that does outside of just taking it by face value what the name is. I think what that does is gives you a helps control your bandwidth of the frequency, so you could, you know, needle width to zooming into a certain spot of the control or of your waveform. This one here changes your sweep mode, and you're going to have it in generally in REP mode, which I believe stands for repetition. And then you got your single, you have a reset, you have manual, log 0, and log. For the most part, I find leaving it in repetition. Now once you're in single, you have this control right here that you turn, and then you can manually sweep it. So leaving it in repetition, REP mode, I believe that's what that stands for. It basically automatically refreshes the screen for you. We have our control right here, which allows you to put it on frequency. And you do not necessarily need to have this control in operation. But let's say you want to, well, since we're already here, check a 10.7 kilohertz frequency. Then you dial this up on 10.7, and then on your function generator, frequency synthesizer, or whatever, you have that on 10.7, it will then peak on screen. And with this control here, then you can move your waveform back and forth, your peak, to the center of the screen here on the graduals. And that will help confirm whether or not you're on frequency. If you flicked it over here on the CTR switch, that stands for center, and then it puts your waveform center screen. But you also have this control here, which will move it back and forth. Now, if you're in center screen, then you want to make sure you have this set to 0, because having this set to 0 turns this function off. Now you see, by cranking the little dial, how fast that number is chugging right along. Well, what if you need fine tune? Well, you grab the control and you pull it out, and now it changed gears on you, and there you go. Gearbox is right behind us. It's kind of cool. It has brass gears. No lubrication needed. It's very nice. This device is pretty heavy. Not as heavy as my IFR, but heavy just the same. It probably weighs around 30-40 pounds. I dig the book out and tell you, but I've already put it up. There's your homework. You can look that up yourself. Here is a wide shot of the back. We have a box here, a little bump out. And on the other side of that's a transformer. Now this also makes a fantastic handle to grab the front, and then you can grab the rear and swing that thing around. You can muscle it around. No problems with that. That's how I've been doing this entire thing. Over here we have some inputs, outputs, our serial number, a standard 3-prong computer, like, I forget what this is, IEC or something like that. Standard computer type 3-prong cable with fuse right there. And then we have our grounding lug right here. And a cool sticker there. And a warning sticker and some kind of purple sticker. And here's a close-up of our ports. We have our XY axis right here, which you can port out to your O-scope or some other kind of plotter. Here we have a pin lift. Again, I'm not a voice of authority on this, but I see pin lift on several things besides this device, and the best way I understand it is basically a switch controlled input or a trigger. Here we have our tracking oscillator inputs and outputs. For our output, we do have a level control right here, and then our tracking oscillator input here, which we have a switch down here that states that reads external reference 100 kilohertz to 100 kilohertz at 100 millivolts and normal. Here we have our LO output. Now I have no idea what LO stands for. In the book it does have little periods in between the L and O, but what its abbreviation is, I don't know. But in the book, as it says here, it does offer a 10 to 15 megahertz output. I'm not exactly 100% sure why or what, but from what I'm understanding, the best way I'm understanding is that this is a voltage controlled output, and by doing this, you're able to control some other device. And then we have our external trigger input. Now I'm going to try to stop saying do your research so much. I'm sure that's getting old. I just really need to drive home the fact that I am not a voice of authority, and I'm probably not one to be asking questions, but apparently the one to bump the camera. But while we're here, let's look at the sticker. And there is our cool sticker. Now that I have this on the big screen and I can see exactly what we have there, yes, we do have our grounding lug here, our 3-port plug there, AC mains, and we have our fuse. Brake screen in case of emergency, I think. And then finally our last warning sticker. And now next we're going to do a full cavity search. Oh no, not yet. We're actually going to spin this around so we can see the other sides. We do have handles on both sides. And as you saw, apparently heavy in the front. And our front again. The other side. And finally, our bottom. As you can see, we got big feet and a kickstand. Now, I'm getting ready to open this up, and in my needed help video, I had something rattling around in there, and thanks to Video Lab Guy, I was able to find out where it went and all that good stuff. Got it plugged in, and it was working. Well, as I plugged that in and I was putting the case back on, I heard not sure if the microphone's picking that up, but there's more debris floating around in here, and that is what we're going to try to liberate, get out of there. There is a section back here that is covered, and I think that's where it's floating around in. Can't remember if it's on the top or on the bottom, but we're going to take it all off and look at it and figure out what is floating around in there. I have ran this for a good 6 hours. Nothing burnt, nothing smelled, nothing. So I'm not sure if we just had some plastic that went EOL by itself, and that's what happened. So we're going to find out what that is. Let me reposition the camera. We're going to open this up. Now, some of my shots may be handheld shaky cam, so I'll try to move the shaky cam as fast as I can with lots and lots of jerks in there. Definitely do that for you, because that's the kind of guy I am. Okay, I got the shaky cam all ready to go, and I repositioned the camera. And now we're going to take the top off here. I would use my overhead cam, but you would probably get my the top of my head, and I don't think everybody wants to see the top of my head, do we? I know I don't. So take it off. We simply have these 4 screws in the corners, and then we've got these 2 right here. And for these, this one here is actually missing the little latch on the inside. And these ones, your standard P2. When I originally tried to take this off, not knowing what I was doing, I wasn't sure what these 2 screws went to, and had a heck of a time trying to take the top off, of course. So now you just pull this off, like so. Case, nice aluminum, so if you ever needed to scrap it and get you some beer money, well, there you go. And there is the top side of this. I believe all the rattling is happening in here. We have the really cool gearbox right here. You know what? Let me fire up the shaky cam, and that way I don't have to repeat myself. Alright, so the really cool gearbox. And then all the rattling, I think, is coming out of there. And down here we have the power supply. Not sure what that board's for. That could be to, cheap guess, switch it over to 220. I really don't know. We're just going to make this stuff up as we go, because I am not as smart as Chris over at All the Gear No Idea. That old boy is really smart, and I'm impressed and elated that somebody of his caliber watches my my channel. Oh, heck, I'm surprised that all of you watch my channel to begin with. So this right here is a really cool box. I want to say this is the oh heck, what am I trying to say? I think this is where the crystal box is. I'm not sure. Or it's where we put oil in. And here we have the gearbox. And then I pull the gear out for fine tune. Nice big heavy clunk. Man-made gears. I went ahead and took the liberty of taking out all the screws, and then I had to pause for the cause I had a phone call. So let's go ahead and take the top off and see what we got. I've not looked in, so this will be the first time for me as well. Plate is just a big chunk of aluminum. And we see down here we've got a bunch of cards. Cards that I'm sure does something really, really important. Like, I don't know, make this thing work. Oh wow, look at all the look at all these. Where's my golden screwdriver? I want to turn each and every one of them. I want to see what it does. Speaking of what it does, this ain't what I had thought it was. I'm a goofball. If you look right down there, that's the CRT. So this is probably going to be the high voltage for the CRT. Can we say goober? So let me grab my flashlight and see if we could look down in the hole. That section's clean. I see no bits and pieces in there. I see none in there. Alright, so I see absolutely no bits and pieces floating around in this section of the cavity. And for those that were wondering about the one part that I found that had fallen off, and we were wondering if it was soldered in or not, and we were going to look for another one. Well, here we have another one. I don't know if it's the same piece, same part number, but it is definitely multi-legged, and it is soldered in there. So I guess I'll need to disassemble and solder that in. Let me see if I could take one of these boards out and look at them. This one right here, this is bolted in by 3 screws, and I'm not sure why. A couple of big fat caps on it. Transistor. So I'm wondering if this is not part of the power supply section. Got some really big heavy resistors right there. Let me pull one of these boards out for fun. Not going to be profitable, but it'll be fun. I have no idea what these boards do, why they do, but they do. So, some of you are familiar with this. You just should theoretically pull these ears up and snap it out of place. But I don't want to break the thing. There we go. Not sure what that's hitting. Need to be careful. It does have wiring. And we have a wire right here, leads down to below. So we definitely don't want to mess with that. Some kind of a switch. Well, that was a retarded statement. Of course it's some kind of a switch, but a switch for something. I'm not sure what. Have a test point more than likely. But you can see all the gold in there. Not sure what this item sold for new, but I'm sure it was really expensive. I was trying to take this one card out, and for the life of me I couldn't. I got it to start wiggling. I was really afraid of breaking off these tabs, but I finally got it to wiggle free. But then I found out why I can't pull that card out. That's because there's a screw right there that bolts that board down to the case. So, interesting. I guess that's a very important board. I pulled the board out next to it, one closest to me. That one came out pretty easy. Fought with the other one to get back in. And on this board, we've got more of those ICs all over the place. We have a processor maybe, and then what looks like a motor. I have no idea what that is. So maybe some of you guys might be able to recognize these pieces and parts. For those that are looking at the schematic, that is the board that I'm looking at. I know the LVD is going to tell us what that board does. Just can't think of it right off the top of my head. And here's a closer look with this camera. Not sure what that is. Part number. And you could also see all the gold traces here. And then another shot of the board. Board number. Well, look at all that gold. And on the back we see that it's not as exciting, not as thrilling, but we could definitely again see that those IC packets are definitely soldered in. And then we have, I don't know, maker's mark or inspector's mark, whatever you want to call it. OPT at the end, could that be option? Is this an option card of some sort? And so that was that card. We're going to pull this one out next. Wow. Have absolutely not a clue what I'm looking at here. Have no idea what these are, nor that. I tell you, those are capacitors. These big things have multiple legs on them. And so do these things. Let me do a close-up with the shaky cam, and then we'll do it with the big cam. Here you can see those things I was talking about. Don't know what those are, or those. So here we have close-up shot with big camera, and you can now see those parts and all that gold. Again, I don't know what these are. I don't know what these are or these. Little foam padding. All right, so I made a comment to somebody in the in one of my videos in regards to this. But look at these. Look at these. Are these RF beads? What are those? And why do some components have them and not others? Spin the board around, and you can see they've got multiple legs. And if we go to the foil side, we can see where they're welded in. And we do have some more stamps. And here is the board number that we're looking at. There we go. It's the board number we're looking at. And this is revision B. The bottom comes off the same way the top does with those 4 little screws, except for it don't have the 2 center screws. I have it tore apart. I don't know what I'm hearing. There's absolutely nothing in here that would So now, I'm wondering if it ain't on the case. Well, I know some of the, 1 or 2 of the screws does not latch, so I'm wondering if that's not what I'm actually hearing. But that's okay, because you guys wanted to see the inside anyway. And I believe in this cavity right here is where the battery goes. Definitely a big battery pack, whatever it is. I'm sure it was lead back then. Have a notch right here. And we have a notch right here Not sure which way the battery would plug in, which way it would angle. However, I do have a plug right here. So it's very plausible the battery went in head first, cable fed out here, snaked around into here. I also have a couple of ports right here, not sure what they connect to. And I'm not really seeing anything over here that would indicate battery would plug in there. So here's a closer look with the big camera. Here's something that I wanted to show you. With AM/FM radio, shortwave radios, you have to restring it from time to time. Well, here's something that would probably be really easy to string. If you notice, we do have a string up there. So we have these two controls that control each other. It wants to ensure that you don't bombard it with a whole bunch of input signal, so it'll automatically try to add attenuation to itself. And you notice this one right here changes. Let me reposition the camera a little. There. So when I change this one, you see that one over there changes too. And as you saw, you could override it with that control. Isn't that cool? All right, let me button this up, plug it in the mains, and we'll fire it up. I guess the rattling all I was hearing was from the case, but we at least got to see the guts. And for that, you're happy. Ooh, you like looking at guts. All right, finally got it all put back together. And we are ready to fire this up. So in the primary camera, you can see the scope. And in the secondary camera, you can see my power watt meter. And that way you can see what it's drawing. And I have it set on watts right now. So let's go ahead and turn this guy on. So there you go, about 26, 27 watts. I will be using my function generator to feed in a signal. And I'll be using a vintage cassette player. Now again, I need to reiterate my positioning on this. I am not a voice of authority on this topic whatsoever. Same with the machine. I'm basically at this point in time a monkey, and I'm going to be flipping levers and switches and this and that. So we'll fumble across this, and we'll get to see a pretty whatever. And that's about it. So haters, don't hate. And if you do hate, make sure you hate responsible. Make sure you know what you're hating for. Why? Have my function generator plugged in with a 50 ohm coax into a 2-prong adapter via a UHF connector into a BNC connector. So I'm sure the ohmage is all mixed match, but it'll get the point home. So we got this turned on, we got this warmed up a little bit. The adaptive sweep, as I was telling you, you can move the floor about. Function generator is set to 1 meg. Let me adjust that. I'm going to go to 1K. Whenever you turn that on as default, it always goes to 1 meg. And the floor is currently set to 10 megahertz. I'm sorry, to a negative 10 dBm. Let me fix that real quick so we don't see that. Alright, so I've fixed that where we see the refresh rate a little better. I don't know about you, but that drives me crazy. So again, I'm just flipping switches and levers and see what's going to happen. I know I need to put that in the auto mode, and then I'm going to turn this down to 0. I'm going to set this into automatic mode. We got that to center. And in case you're wondering, I'm just that fast. Have my shutter speed set to 1/15 of a second. Get rid of that. So let's now turn this down until we can get the input sensitivity. So according to the book, what that means right there is that's outside of bounds. But we can adjust this. No, that's all the way. So for whatever reason, that's outside of bounds. This is our spectrum. Clean that up. So there's the bandwidth switch. So we're at 300 hertz, 100, 30, 10, 0.3, well I guess it makes no difference, 0.3, 0.1. And over here is the frequency span. We're currently at 2, 5, and let me readjust, 2, 1, so this is kilohertz, 5, 2, or 0.2 and 0.1, 50 hertz, 20 hertz, 10 hertz, 5 hertz, 0 hertz, hertz donut. Oh, so let's go back to 0.2. I'm going to take the center switch and I'm going to put it over to start. That shifted that wall that way. And again, we're at negative 10 dBm, so the voltage is way down there. And so if I click this over, I think I'm at a -10. I'm sitting off to the side. I really can't see. So there we go. Our signal and probably harmonics. Yeah. There we go. Looks better, don't it? All right, so if I wanted to measure this to confirm my device is actually spitting out a 1000 kilohertz tone, and then we got that all nice and pretty, I'll go over here to center, and then I'll take this and I'll crank it until I get to a 1. There you go. Fine. So from what I'm seeing, we got this even with the 0 up here, the line for 0. And I could take this and I guess I split that where I have even division on either side, and there's my 1000 kilohertz. So that's saying that my signal generator, function generator, is putting out a proper frequency. And over here I'll put this sweep mode over to single, and you see that I just kind of froze. I could take my control here. Well, actually this is a horrible example. All right. So what else can we do? Well, I can't figure out what I'm trying to do. But you want to see this thing harmonizing? Look at that. So I'm at 100 hertz at 50 millivolts on the function generator, PEP. And again, flicking switches, mashing buttons. I'm sure in time I'll get this all figured out eventually. Alright, I see my refresh rate here is too slow on the camera. Let me adjust the camera real quick. Stand by. Alright, camera's back at 1/60th of a second. So now you're watching this in real time. See, no more fast hands. Now I'm just slowing it down. It's 0.1 second. Alright, so let's look at 60 hertz. Let's go to 1 hertz. Let's go to 400 hertz. Trying to make that bigger. 1000 hertz. And again, I'm at 50 millivolts. Let me change that to 500 millivolts peak to peak. Let me drop back down to 1. Oops. Let me go to 1 hertz, 500 millivolts, 50 hertz for those across the pond, 100 hertz, and then we'll go back up to 1000 hertz, 50,000 hertz, now we're at the range of the device here at 50,000 hertz. But let's go ahead and take it all the way up to 100,000 hertz. And we lost it. Let's go ahead and drop it to 60,000 hertz. have something at 60,000. Let's do 70,000. $100,000. Ah, all right, got a signal. All right, so that's 100,000. So we're over twice of what the device says it's capable of doing. Let's go up to 200,000. Let's go for 1 meg. So it definitely does read further than what it says it's capable of doing. How accurate is it? It's another story. All right, let me pause for just a moment and hook up a tape player to it, and let's look at some audio. Before we go into the cassette tape and play some music, or look at, I don't know, Dancing Bears, thought I would take a moment and show you this really cool screen. And that's it. That's all I wanted to show you. No, I'm kidding. What you're watching, what you're looking at, is this device is actually picking up all the electrical noise that's in my office from all the power supplies and just filth in general, electrical filth. Now, as you see, we have absolutely nothing touching connected to the probes in front. I'm going to take my hand, nothing in my hand. So you see there, it picks up the, it digs my vibe, I guess is what I'm trying to say. Speaking of digging vibes, let me turn this down a notch. That's sensitivity there. I'm going to take a remote control. I'm going to push a button. Put it really close. Ah, first time I saw that. Put the remote control close, and I ain't even pushing a button. Right? Hand on no button. Just put it close. Well, that's cool. Alright, now this time I really am going to push a button. Watch the birdie. See that? Hit the button. Is that cool or what? Anyway, enough of that. So I'm going to take this with that. I'm going to stick it in there. Now that I have a antenna connected, really sensitive. Hello, 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 can you hear me? CQ, CQ, CQDX, CQDX. Why, this is somebody. Over. Hi, hi, ho, ho. Yeah, shut up. I'm going to take one of these things right here. This is what the Walkman used to look like before it was a Walkman. This will be a subject for another video. So I'm going to push play. I'm going to take this and I'm going to stick it in there. Make some adjustments. So now we could look at our waveform. Remember earlier at the beginning I was talking to you about the digital aspect of this scope. So if I want to capture that, all I have to do, I believe, is hit store. Right? And then I turn this off. And then I hit play again. And if I want to make that go away, I say the magical words. Clear right. Shazam. Oops. Blank store. Shazam. It's one of those. Oh. There we go. Just keep playing until you get the combination. Again, I'm not a teacher. I don't know anything. Kind of cool, huh? Already play with that button. Let's see. What button can I play with? Input sensitivity button. And this one here is the amplitude ref level. I don't know. I can't see it that well. And we're on linear, log. You go from dBV lean to dB 600 ohm. And this here is 10 dB. I can't make it out. This is 10 dB. Okay, enough playing with that. Okay, so this next segment, I have a cassette tape with a tone of 3000 hertz cyanide pattern on there. I'm going to go ahead and hit the play, and we're going to watch it populate. And we're just going through the leader at this aspect. There we go. So just to confirm. Oh, watch your ears. So that's now earlier when I did this, well, not earlier, when I first got this machine and I'm sitting here playing with all this, I was actually able to see the sine wave, or the wow and flutter anyway. So that looks pretty awesome, huh? Would you agree that we're looking at wow and flutter? I mean, I know this is going to be our fundamental, and these are going to be our harmonics. But the way how it's fluctuating, would you say that that's wow and flutter? Wow, man, that's fluttering. Well, I'm unable to replicate what it was. I thought I saw at one point in time. I thought I actually saw a sine wave at one time. But apparently... You notice when I'm turning this that this here is also making adjustments to that string we saw earlier. Well, I would imagine more time playing around with it would definitely tell me if my memories are all skewed or correct. But you could see where the advantages of such a device would definitely come in handy. It will sit on my desk right next to the IFR, right over there. I will use it. Not sure how and when or where or why I'll use it, but I'll use it. I'll figure it out. And there's one other thing I want to show you before we terminate this video, or in this video. I also wanted to say one thing, and we could all agree upon this. Mr. Carlson, I am not. Oh, actually, there's two things I want to show you. So let me set up. I'm going to turn this off. So I'm going to take cables and plug them into that. And you can see we're just crocodilators on the other end. I'm going to take a Radio Shack dynamic microphone, right? Nothing snazzy of a microphone. And then I'm going to clip negative, positive, test, 1 2 1 2, sensitive, testing, 1 2 1 2, test, test 1 2 1 2 1 2 1 2, testing, 1 2 1 2, and the cow goes moo. The French cow goes le moo. Testing, 1 2 1 2, test. CQ, CQDX. Testing, 1 2 1 2. This is Whiskey Tango number 9er, over and out. CQ. Test, 1 2 1 2. 1 2, buckle my shoe. Audio. Hello. Audio. All I'm doing here is the sweep time, just lowering it down in time. 1 2 1 2 1 2. CQ, CQDX. This is Whiskey Tango 9er, Foxtrot X-Ray Zulu, over. By the way, that's not my call. I made it up. Watch, I'll make another one. Victor Edward, number Z. Fred Z12, over. Audio. Oh, it's too slow. Audio. Testing, 1 2, audio. A, B, C. A, B, C. A, B, C. A, B, C. 1 2, free. Audio. Chaka Khan, Chaka Khan. I don't know the rest of that song. Hello. Oh yeah. Oh yeah. Oh no. Maybe. Isn't that cool? Now what did I do? Great. I broke the darn thing. Alright. Okay. Wonderful. Spectacular. So it works. One more thing and we're out of here. So I just unplugged the mic. Got a question to ask you. And I'm sure you know this because you're really, really bright. Why, say before 1980, on applications, devices, was the word microphone abbreviated M-I-K-E as in the man's name and not M-I-C-K-E-Y-M-O-U-S? Sorry. Of course, we all went there, right? How many of you actually went there as well? All right, so what I'm trying to do right now is I'm setting up my function generator, and I'm going to do a sweep of say 5 kilohertz or 5 hertz all the way up to 50,000 kilohertz, and we're going to do that continuously. Let me drop the power down to 1 volt PEP. So let me get this set up, and we should see the thing . So we're doing this at 60 seconds. So it's taken 60 seconds for it to go one way to the other. There we go. All right, so I think that's it right there. I think that's the signal coming out of the generator, and the rest was just noise and harmonics and whatnot. So here we're scanning the entire band, 5 hertz all the way up to 50,000. All right, well, I think we get the picture. I don't think we have to sit here and wait and then have me in the video. So while that is scrolling across, let me go ahead and finish the video right now, right here. I hope you guys enjoyed the video. I hope this was everything you were waiting for. I hope I was in depth enough with the skills and the knowledge I have. I hope it did something with your curiosity. I don't know what. Entertained it. There we go. So with that, I will say 7 threes. And thank you for watching my long-winded video. I wanted to do it long to ensure it was in-depth enough to hopefully answer questions or whatever. I don't know. Anyway, enough of me. Talk to you guys later. Thanks for watching. I enjoyed it. Hope you did as well. See ya.